My name is Bonnie Kaffa, and I'm with Leapfrog Scientist. Welcome back from a very long summer break. We are back with the newsletter, and today we have a special guest with us. So we have David Kane interviewing for our first ever video newsletter. So welcome, David.
Thank
David,
you.
I met David back several years ago while at Altria. David's a friend and colleague, and he is with Rocket Science Consulting. Thanks for joining.
Yep. You're welcome.
So David, how about we start off with you just telling us a little bit about Rocket Science Consulting and maybe some of the services you offer?
Okay, well, and Rocket Science Consulting is a fancy name, but we really don't do rocket science. We do science. What we do is we provide science-based solutions to business and technical questions of all sorts. So I have a strong background in the tobacco industry. So working with tobacco and cannabis companies is, part of our focus and major effort. The types of things we do, we help with regulatory questions. Some of the things we've done recently, writing reports for data, do a lot of work with particle sizing data because that sort of falls under my expertise, can review and evaluate data in other areas as well. We develop, and we, by the way, is mostly me, develop models of, thermodynamic processes, of aerosol processes. We've developed recently a model looking at vaporization as it occurs in e-cigarettes, which you can use for predicting delivery, for example, of your active ingredient or of trace components, flavors, or contaminants that might be in the e-liquid to show that there's very low likelihood of them being in the aerosol. We help set up scientific methods, particularly like coming up with ways to test and measure things that you can't get at, easily, either like properties that you can't read in a table, like permeabilities, or other things like that.
Okay, nice. It's a wide variety of services. What about validation? Do you help with validation studies for some of these methods?
Yeah. I mean, we can help with, or I can help with designing studies, statistical testing, also help you figure out right sample sizes,
Okay.
All sorts of stuff like that.
Okay, so let's talk a little bit about your journey. So what initially inspired you to pursue graduate studies in physics?
I guess growing up, I was one of those, science geek kids. I always wanted to know how things worked. I was taking things apart and not always getting them back together to understand what was going on, and liked, explaining to people what was happening. So in high school, my family moved to Wilmington, Delaware. Wilmington, as you may or may not know, is the home of DuPont chemicals. So most of the people I was in high school with were, children of DuPonters and either planning to go into chemistry or chemical engineering, for college. So I looked around, it's like, I don't want to go do all the same things that everybody else here is doing. So I opted to go into physics, which, was, I think, a bit, of an odd choice. I wasn't always driven towards physics, but I did it, and I think it was the right thing for me because has a lot of that fundamental understanding of how things work. So, and physics applies to chemistry, and it applies to biology and all these different areas. So I didn't know what I wanted to do with physics. I thought I wanted to teach high school. So I did all the coursework and stuff that I needed to get certified to teach high school, and did that for a couple of years and decided that wasn't what I wanted to do the rest of my life. So I ended up going back to graduate school. And I didn't have, I started in graduate school. I wasn't a great student as an undergraduate. So I started as an unmatriculated student, so not enrolled in a degree program, and eventually got in and got an assistantship, and needed to find research to do, and wanted to work with nanoparticles and stuff like that. And I was sent to a professor in the chemistry department who did some work with nanoparticles and ended up on a project related to nucleation. So and from there, it's just sort of been, sort of those logical steps, one after the other after the other.
Yeah, very interesting. I think there's a lot of us too that thought we were going to do, take one approach, one career, and then it morphed into something else. And it's all experience that you're gaining along the way, right? And never, in my opinion, a bad choice, right? For any decision, you're gaining experience, learning knowledge, and then you're applying it to a different area. So I think a lot of the questions we get are from young, junior academic scientists, and they're always asking, how do you transition out of academia into industry or consulting? So I thought maybe you could talk about your transition, because you were in academia and then you moved to industry and then you moved to consulting.
Yeah, so after graduate school, I did a postdoc, and I was looking for faculty positions. So and so I was applying for faculty roles, and got a few interviews, and eventually got one offer. But at the same time I got that offer, I got an offer from Philip Morris for a postdoc. So my wife was I was living in Delaware at that point, but my wife was from Richmond. We just had our first child, and Philip Morris headquartered in Richmond, and it would have been going back there. And so that's how I applied for the position. And it was a postdoc position, so temporary. I didn't think I'd end up staying very long, but yeah, well, that's a different story, right?
Yep.
But and so I had this faculty position offer, but it sort of morphed from a full-time assistant professor when I applied to a 2 or 3 year term position, because I guess they didn't get their funding for the full-time. And then and then salary-wise, it was about 60% of what I would have made as a postdoc. And so the closeness to family and all that, won out. So, and I went to Philip Morris at the time as a postdoc with the goal of setting up, Aerosol lab for them. And, it was a no-brainer, and I didn't think I'd be there very long. And I was applying for other positions, academic and industry positions. And then one day, actually, I had an interview with a company that makes nebulizers. and flying back from an interview, I realized that, I would be like the aerosol scientist at that company. And mostly they were a manufacturing company. And, coming back, I think the day after I was out there, I sat in a lecture at Altria on nanotechnology or something like that. I'm like, if I go out there, I will give all this up. So I went and told my boss that I'd gotten an offer from them, but I wasn't going to take it. Would keep applying. And then I guess that sort of scared him, and he went and I think I got an offer from Philip Morris a couple weeks later. So he called me into his office and said, "Here, we're offering you full time." So that's how I ended up transitioning from academia to industry. And I think industry jobs are, well, PhD level jobs probably aren't a lot more plentiful, but a little bit more plentiful. But definitely lucrative. Bigger companies can give you a lot of freedom, and you have a lot of collaborations and interactions and stuff.
Yes. Yeah, and I think we've been talking a lot about aerosol science, but maybe we should talk a little bit about what exactly is an aerosol scientist.
Okay. Well, first of all, I guess when you say aerosols, a lot of us just think of those spray cans. Mm-hmm. And spray can is an aerosol generator, basically. But an aerosol is a suspension of particles in a gas. So the spray that we make with the can is an aerosol because we have these droplets. And it's raining out there today, so the rain is actually an aerosol. That mist is an aerosol. Smog, the air we breathe, those are all suspensions of particles in a gas. And it turns out things like cigarette smoke and cannabis smoke, they're aerosols as well. So and vapes. Vapes are an aerosol generator. So they're particles suspended in air, and cannabis smoke and cigarette smoke and vapes they're very complex aerosol compared to what we see in everyday sprays and stuff. They have very high concentrations. They have a lot of different components, and a lot of components with different volatilities. And then they're also generated in short puffs, so they evolve rapidly in time, and they can evaporate and disappear, or they can absorb water and grow. And so all the dynamics there are interesting and exciting and really relevant to the experience that you get from smoking a cigarette or vaping.
So definitely regulators are requiring aerosol science, but you think it's also, from your last comment, it's important for companies to look at aerosol science in terms of developing a better or a really good consumer product. So early in the product development stage as well.
I think the earlier you involve, somebody who understands the aerosol behavior, the better. Yeah. So, you can go, pretty far just by getting some cotton and wrapping a wire around it and sticking it down in a liquid, right? But if you want to design a product that, more closely mimics the smoking experience, or has particular properties. Understanding the aerosol is an important key to that. So when it comes to inhaled aerosols, there's sort of, you have your device and you have your e-liquid, and they both feed into the aerosol separately, and then how they feed in completely depends on completely changes the experience. So
yeah, I think that we could definitely talk about e-liquids and aerosol and devices for quite a bit, and I've got some more questions, but for the sake of there might be another video on specifically just on e-cigarette aerosols. But why do you think, aside from what we talked about, it's important for companies that are making e-cigarettes or other reduced harm products to understand the physics and chemistry of aerosols, whether it's looking at the device or, as you just mentioned, looking at the e-liquid or the solution that's used to aerosolize?
Well, I mean, there are a lot of reasons why it's important. I think the biggest one is probably because the aerosol is your delivery mechanism. So you're taking your active ingredient, whether it's THC or some other cannabinoid or nicotine, or you may use this sort of technology for delivering other pharmaceutical actives as well. You're taking it from the liquid, you put it into the aerosol, and then it gets delivered. And where it is in the aerosol, whether it's in the vapor or the particle, has a huge effect on where it's delivered. Vapors are mostly going to be delivered up here, and particles get carried lower. The size of the particles will control how deeply into the lungs it gets carried. If they're too big or too small, it's going to end up, mostly in your mouth. And, if it's the right size, then it can get carried deep down into your lungs. So that's, major thing is in controlling the delivery, but there's lots of sensory aspects as well. The aerosol is really controlling the release of the flavor. So with vapes, most of your flavor is odors, so or odorants. So they're mostly in the vapor phase, but they're going to be partitioned between the particulate and the vapor, and how they get released and when they get released, has an effect on how they're perceived. So.
Okay, so lots of reasons to call in an aerosol scientist early in on product development stage, or later in the regulatory process when you're filing a submission.
Yep.
Okay. So what do you find is the most rewarding thing about the work you do as an aerosol scientist and then as a consultant for others interested in consulting?
For me, what I find most rewarding as an aerosol scientist is getting to solve some problem that somebody else has been tinkering with for a long time. So
that was a very scientist answer, by the way.
Oh, sorry. Yeah, I want to come up with a specific example, but I think the specific
no, it's great. I think that's just the definition of a scientist, right?
And then as a consultant, what I like is getting to work on different things all the time. So I get some routine work, but a lot of what I do is completely different problems from the things I did yesterday or last week or whatever. So I've looked at I think I talked about this earlier, but transfer of trace components. I have one client not in the tobacco nicotine area. One client who's looking at a way to authenticate works of art. So, for example, you send something out, you're a museum, you loan out your Monet to somebody, for an exhibit, and then, do you get back the Monet you loaned out? So, I get to apply a lot of statistics and help. And basically, I'm developing statistical methods for him so he can take his measurements that he's making on an object and make a quantitative judgment about, yeah, this is the same object, or no, this isn't the same object.
Very interesting.
And let's see, I'm trying to think of, talking to people in the petroleum industry about, how they can reduce volumes of brine that, eventually they're going to pump these brines into, underground and, put them back in the well that they got them out of. But, how can they reduce the volume that they have? So, have such high waste. So,
okay. And to be unbiased, I'll ask you the opposite question of, I guess, what's the biggest frustration with consulting?
For me, the biggest frustration is really having to find the work, because it doesn't, when you have a full-time role somewhere up the chain, there's a manager that's, giving you, direction. We need to work on this, or, this is a key. Even if you're not getting like specific assignments, do this, do that from them. Somewhere up the chain, there's somebody saying, I need this done, I need that done, or I need. And as a consultant, you don't have that. You got to go out and put yourself out there and do a lot of networking, talking to people, and sending emails. And what really gets me is the number of non-response that you get when you do that. So
yeah. And I know as an introvert, it's very hard for me to do that, but I definitely try to do it as much as possible. And I don't know for you if you're an introvert or extrovert.
I'm more introverted, particularly when it comes to having to go out and talk to people that I don't have good relationships with. Yeah. So that's tough.
Okay, so last question that we have time for. So what advice would you give an aspiring scientist that's interested in either aerosol science or transitioning into industry from academia?
Well, I guess the advice I give to people, if you're looking for a job in industry, is use your contacts. Look at your network, figure out who you know, and talk to those people. Try and find a champion who will, put in a good word for you. So maybe they have something at their company, maybe they'll just talk to a friend and, at another company. Because that seems to be the way people find jobs now.
Yep. Great advice. Okay, well, thank you, David, for being the first guinea pig on the first video newsletter. Appreciate your time.
You're welcome.